This is Kevin from Performance Trends, and today we're going to show you how you can use the dowel pin location to actually figure out how this cam is timed in the motor, assuming you know where this dowel pin is supposed to be located. If you don't have a dowel pin, sometimes you might have a keyway, and then we provide these little magnets that can go into a keyway, and we'll find the center line of this cylinder here, just like the dowel pin, and the center of that cylinder should be the center line of the keyway. So, if you, like this is a small block Chevy cam, and I'm going to go into our test and cam setup here, and the important thing for this is a couple of things. The TDC method. Typically, if you're not going to use the dowel pin, most people are going to say, I'm going to tell you where the intake center line is. Let's say 110 degrees intake center line. And you measure the cam, it puts intake number 1 at 110, and then everything else falls out reference to that. But if we're going to use the keyway or the dowel pin, we got to use user finds TDC with sensor. Now there's this other one here, user finds TDC with stops. That's for using piston stop if you're measuring the cam actually in the motor. Rotate the cam against the piston stop one way, then go rotate it the other way, and the software will split the difference and find TDC that way. But we're going to use the sensor on the stand. Now, we have our small block Chevy like this is, and it comes with a template. And part of the template is the layout details. Okay? This is firing order and such, lobe layout and stuff. And the other thing we have in here, and this is just a default, but in Don Hubbard's book, he's got a bunch of these listed. It's older stuff, but he says for a small block Chevy, the dowel pin should be 53 degrees clockwise here from top dead center in cam degrees. And you think, what does that mean? What it means is, and I'll show you here in a second, this is a typical profile looking at the end of the cam, intake and exhaust lobe. And what I'm going to do is I'm going to put this cam here at roughly that position, because this point, when both of them are open a little bit, is typically close to TDC. Not exactly, obviously, but it's within 10 degrees, 15 degrees of top dead center. So I'm going to rotate this cam. Exhaust number 1 is this first lobe. Intake number 1 is the third lobe. And I'm going to rotate this till, that looks like we're about there. We got a little bit of lift at both at top, right above the cam for both of them. And if you look at the dowel pin here, if this is top dead center, we are roughly about 53 degrees clockwise from top dead center. So that's what that means. Now you can't eyeball it and be precise by any means, but it's just showing you what that precise number there at 53 degrees, what that means. So we're going to now actually use this information to index this cam based on the dowel pin. And we're going to go up here and do recording. We've got nothing recorded for lobes and stuff yet. And you're going to see when you made that setting, we got a new feature up here, set TDC, press F4. So I'm going to press F4, and it gives me a little information. It's trying to walk you through this. It says the sensor must move up at least 1/10 of an inch and down, up and down, to be accurate. So we need at least 1/10 of an inch motion. I'm going to back this up because we're going to be turning it clockwise. Okay? Clockwise when viewed from the front. So I've got this now, so you can see that's moving up at least 1/10 of an inch on this universal flat here. And it says press F5 now for further instructions. And it says after you click OK, do the rotation. And the program will rotate or beep at you when you've had enough rotation. So I'm going to click OK. The timer's going. And I'm going to rotate this thing to find top dead center, basically, or center line of that dowel pin. And it says TDC measured successfully, a bunch of other information. And it says, do you want to use a preloaded setting of 53 degrees clockwise from TDC for timing? I'm going to say yes. And if you said no, it'll give you an option. Well, what do you want to call it? And the useful thing might be 0 or something else. But since we believe that 53 degrees is probably pretty good for this, I'm going to say, yep, we want to use that. And now it's ready to measure intake number 1. Okay, I've moved the universal flat, because this is a flat tappet cam. I've moved it down here to the 3rd lobe, which is intake number 1. And since it's flat tappet, I'm going to keep this universal flat on it. And it's going to act like if we had a round flat tappet on it. A couple things. This this magnetic locator, that was flipped out of the way because it got in the way for measuring the dowel pin location. But when you get done, you can flip that over, and it is kind of nice. The magnet keeps the cam from going that way, and because it's screwed down here, it can't go this way. So it's really nice, simple way to keep things on the V block fairly nice. The other thing I should mention is this universal flat is nice and thin and flat. It lets you get up right alongside this journal here. So even if the dowel pin doesn't stick out very far, you can still get that on there to find the center line of this dowel pin. So anyway, right now we're on intake number 1, and we're going to measure intake number 1 based on telling the software that this is 53 degrees clockwise from top dead center. So we're doing our measurement. Got the nose of the lobe pointing straight down. We do F1 to start recording. Here we go. Clockwise. And there we go. And if we close out of here, and there you can see, based on that dowel pin being 53 degrees clockwise, it says our intake center line is 104 degrees. So if you can trust that you know where this is how you'd measure, index the rotary encoder on a cam by using the dowel pin and not just arbitrarily saying that this center line of this intake number 1 is, for example, 106 or 110 or something.